is moving farther and farther away from the origin, the value of f of x is going to be lower and lower and getting closer to the x-axis. You see the value getting closer to the x-axis. In other words, f of x is approaching 0. And it's never hit 0. It's always above the 0, as you know. The x-axis right here is actually the horizontal asymptote. F of x, when x goes to infinity, it's always a little bit positive, a little bit above 0. But it's getting closer and closer to 0. Okay? And one more time, the equal sign right here doesn't mean that the function is equal to 0. All we're saying is the function is getting closer to 0. Okay? And more precisely, if you put a plus sign on top 0, people understand what? It's approaching 0, but always a little bit above 0. Similarly, what if they ask you this? You guys are going to see this in the homework. 1 over x minus 2, x approaches negative infinity. Now what? We have x, okay, and x go all the way to the left. And what happened to the function? Function f of x also getting closer and closer to the 0 value, or the graph is getting closer to the x-axis. Now, the value f of x is always a little bit less than 0, or the graph is always below the x-axis. Still approaches 0, but 0 minus. Okay? So far, so good. And actually, this is a sign to tell you what? The line y equal to 0 will be the horizontal asymptote, because when x goes to positive infinity or negative infinity, the graph of the function approaches a constant. In this case, equal to 0. And that's the horizontal asymptote. Horizontal asymptote at y equal to 0. All right. Now, this is the value 2 right here. What if I take the limit of 1 over x minus 2 when x approaches 2 from plus sign? So x is right here. X getting closer to 2 instead of go to infinity. Now I'm moving x in this direction, getting closer to 2. What happened to f of x? When x getting closer to 2, f of x getting bigger and bigger and bigger. The closer the x to 2, then the bigger the value of f of x. Okay? And where is that going to? It's going to infinity, right? Go to infinity, going up forever. Never hit 2, okay? X never hit 2. F of x when x equal to 2 is undefined. We don't have f of 2, because when you plug an x in 2, 1 over 2 minus 2 is 1 over 0, which is undefined. But it is okay for x equal to 2.00001. X is a little bit bigger than 2 is okay, right? Not 2, but closer to 2 is okay. When x is closer to, f of x is shooting up to the sky, to infinity. And similarly, limit x approaches 2 from the left, the function 1 over x minus 2 will be negative infinity. X goes to 2 from the left, the function is going down to negative infinity. Those two indicates what? You have the vertical asymptote at x equal to 2. Either one of those two will tell you this. Okay, after having the basic concept or definition of intuitive definition of limit, we show you the case where limit go to infinity, or the value of the function go to infinity when x go to a closer number. All right. And pretty much this is the end of 2.1 and 2.2. With this section, I claim that we haven't given the formal definition of limit yet, but at least you have the idea. I'm just trying to summarize the whole section today. For 2.1, we talk about tangent lines. We have a secant line to start with, and then within the second point, getting closer to the first point, the secant line becomes the tangent line. All right? And the slope of the tangent line is really the limit of the slope of the secant line. That's what they're trying to tell you. But we haven't talked about that yet formally. Okay, and then for 2.2, we're talking about limit. It means what? when the input x is getting close to a value, then the output y of the function, the value of the function is going to get close to another value, and that including infinity, plus or minus. Alright, and this is the end of the first two sections of chapter 2. Hope you guys enjoyed the video clip. One more time, should you have any question, please feel free to ask. Thank you and have a good day.